Okay. So the next thing you're going to do, it's basically called potential divider. Potential divider. So about potential divider, just want to tell you that it is basically a series circuit that has a variable resistor or two different resistors connected to it. And like that. Now, obviously, you will have an EMF. Suppose right now we have EMF for 6 volts. Your variable resistor, let's call this R1 and of 200 ohms set to this value, and then we have a fixed resistor R2 which is also 200 ohms, and we are interested in eh? Salma, I am speaking. You guys can hear me?
Yeah.
Okay, Salma, you need to see your speakers. Whether she's not hearing. Okay. So I was saying that you want to basically provide some voltage or control voltage across this one. Let's call this V out, the potential difference across this one. So this has a derivation that is included in your course, and the formula is very, very important as well. So we're gonna first do that and then move forward. So the derivation says total voltage that we have is the EMF E. Then the total current, because this is a series circuit, so obviously the current is going to go like that. So total current will be I. And right now, the total resistance will be R1 plus R2 because they're in series, right? Now, what you do is, in the first part, let's divide it up from here. V, is equal to IR. So the EMF is I, EMF is E. We have the current that goes through the total resistance. So we have this circuit. We're going to make I the subject, and it will be E over R1 plus R2, like that. Let's call this first equation. Then, on the other side, use V is equal to IR. The V out voltage will be equal to the current that's passing through R2 only. We're going to make I the subject of the equation, and V out will be equal to R2. So this is the second equation that we need. All right. Then what you do is you guys need to substitute this. You guys need to substitute, and when you do the substitution, it's going to look like this. I will be equal to I. So EMF R1 plus R2 can be written as V out over R2 because we're interested in finding V out. So make this V out subject. So it's going to be R2 over R1 plus R2 times the EMF, like that. So this is the main formula that we needed to derive. Now, the important part here is that I want to basically point out, if you notice, the resistance against V out will be on top, and at the denominator we add all the resistors. Alright, so that's why it's R1 plus R2. And as you can see, because R2 was against V2, V out, so we have to put R2 on top. Now, using this formula, it's pretty easy. You don't need to find current or anything. What you gotta do is simply rely on, if I want to find V out, obviously I need R2 on top, so I'm gonna put 200, and then 200 plus 200, both of them added together, times the total voltage, which gives us exactly 3 volts. So that would be given. So it's basically the resistance is half and half, so they will just divide it equally. Is it clear, everyone? Any questions here?
Yes. No.
Good. So you can write this down, please, and then we'll look at a question. Furkan, hello. Please come on time. Okay. When you're done writing, please let me know so I can go forward. On Wednesday, I will be taking your test from the same two chapters, current electricity and DC circuits. We've done the current electricity, I think, worksheet already. We will be done by the worksheet of this today, and then we'll go forward, okay? So that we have just one topic left. Okay. Now, kids, for example, they have given you a question. It says total resistance is 600 ohms. If V out is equal to 2 volts, find ratio R1 over R2. This is the question. They have also given us this circuit where there is a rheostat. Rheostat is just a variable resistor. And this EMF is 6 volts. And they've connected a voltmeter such that is it right here. So this section they've shown as R1. This section they've shown as R2. All right. Well, technically, wait, let me just correct the drawing. It should be a bit less than that. Somewhat like this. This is V out. This is R1, R2, and this is R1 in the question. Okay, so you're going to find that. So first of all, we should understand whether you have two or just one. You should remember that voltage can be found out through a variable resistor like that at any point. So we're gonna write the formula. Obviously, V out is against R1, so we're gonna write R1 on top, and then we're gonna add R1 plus R2, and then we'll multiply EMF along with it, and V out will be found like this. Right now, we know the total resistance, which is R1 plus R2, that is 600, and the EMF here is 6 volts. Also, V out is given as 2 volts. So we can find this out. We can find R1. So it will be 2 into 600 divided by 6. So it's going to be 200 ohms. Alright, kids. So you got R1. We can find R2 as well because we know R1 plus R2. Let me change the color. We know that R1 plus R2 is 600. If R1 is 200, then R2 is going to be 400 ohms, like that. Now we want to find the ratio R1 or R2. So we can say R1 over R2 will be 200 divided by 400. That's going to be 0.5, like that. Is it clear, everyone?
Yes.
Shazib, everything is clear? Asma, Salma, Zirwa,
All clear, sir.
Maz, what about you? Furqan?
Yes, sir.
Okay, very good. Write this down then. Now say this point is A, this point is B. So we should understand, just write a note here, that if we move the junction from A to B, the value of V out will increase. And why is that? Because for same current, voltage is directly proportional to resistance. So as you cover more of the area of the resistor, you're going to get larger voltage as well because now you're targeting higher resistance. Okay. All right, write this down, please, kids. Now, for the crash course, when you register, I will be sending you a workbook, and you will have like more than 5 days. Get it printed, please, if you're not working digitally, so that you have access to it. Okay, when we start the crash course from the first week of January, so you must have that before that time. Okay. Now, going to the next then, which is basically the potentiometer. Now, potentiometer is the last device and this device is used for a couple of things. Number one, comparing EMFs of cells. Number two, comparing potential difference of wires and resistors. So that's the two function of it. Basically, potentiometer is sort of a device. It's not a device, it's sort of a, you say, a circuit built into a device where you will always use a length of wire. Let's call this AB right now. And with a known battery with an EMF like that. So this length of wire AB, so length AB, they will always give it to you for 1 meter or 100 centimeter, right? So it will be the same for all questions. And then what you do is another cell of maybe an unknown EMF is going to be connected to a galvanometer. Galvanometer gives you the direction of current, by the way. And there will be a jockey. Jockey is like a connector called J right now. All right, so like this. Now, what you guys need to remember is that how it function is that we move the jockey J along the wire till galvanometer shows null point. I'm going to explain this null point. Null point means current in E2 will be 0. Current in battery E2 will be 0 when you move this, right? At one point it will be like that. And the reason is that this length, which we're going to call length AJ, at this length, the voltage AJ will be equal to the EMF2. So we can say here, it means at null point, voltage AJ will be equal to EMF2. And that's the only situation where it's going to show you 0 current on the galvanometer. Now, if they ask you why is that, because current can only move from higher potential to a lower one. Right now, if the potential difference is 0, current will be 0, because both like potential AJ and E2 are same, so there's no difference. That's why there will be no current. The only equation that you're going to learn in this is that the length AJ over length AB will be equal to, if this one has voltage AB, will be equal to voltage AB over voltage, oh my god, voltage AJ over voltage AB. So voltage and length are going to decrease or increase in direct proportion. That's why we're going to use this formula to find this. Now let's suppose that we're interested in finding E2. and this length comes out to be 40 centimeter. So we can simply use this formula. We can say this voltage, that was given as 10.0 volts. So we can say length AJ was 40 centimeter. This is for E2. Okay. And length AB is 100 centimeter, as you can see. Voltage AJ we don't know, and voltage AB is 10. So if you multiply that, it should come out as voltage AJ to be 4 volts, right? Now what you do is, we must remember from this point, if galvanometer shows null point, which means current is 0, then voltage AJ will be equal to EMF2. Hence, EMF2 will also be 4 volts. Is it clear, everyone?
Yes.
Okay, right. And do not forget this formula. This will go a long way. Okay. Something quite easy. Now, suppose they want you to compare voltages of okay, now let's check it out. Now, let's do a question of comparing EMFs. Now, this is super simple. Suppose you have a circuit, a potentiometer. We have connected it with a wire AB. This wire is obviously 100 centimeter, but we don't really care about that. There's one cell or a battery that's connected like this with a galvanometer, and it is set to a certain position where the galvanometer shows 0 reading. So let's call this EMF2. Then there's another battery that is connected like this, and the galvanometer is set as well, and it is the jockey is moved to a certain point from where the current it shows is 0. This is EMF 1 as well. Now we have measured this length from here to here, right? Let's call this length 1, or let's call this A, B, C, D. That would be better so that you guys can understand. A, B, C, D. Okay, length AD, and then obviously it will have, if the current shows is 0, and then the other length from here to here is given as length AC. So how do you find this? If the current is 0, then you guys should understand whatever the voltage AD is and whatever the voltage AC is, voltage AD will be equal to EMF 1 and voltage AC will be equal to EMF 2 only when current in these two cells are 0. Otherwise, it won't be. So you must bring them to this 0 point. What you do then is very simple. The first length is length AD. You divide it by length AC. So the EMF against AD was E1, EMF against AC was E2, and that's the only thing you're gonna use. So you can create these formulas from your own. They're very dynamic in that sense and quite easy. So whatever length represents that jockey, and if there is a current 0, then obviously you can relate it directly to the EMF against it, like that. Is it clear, kids?
Yes.
Okay, write it down. Okay, now next. The last thing in this chapter is a very repeated question that comes in the exam, and that is when they're going to give you a circuit, and from that circuit like that, they've given you EMF 1, and then they have attached a cell, and they've said obviously the cell has an internal resistance R. This is EMF 2. At one point at the galvanometer, the current here is 0, and this is the whole cell we want to find the EMF of. So the question they would ask you is that if galvanometer shows no current, then why, if the galvanometer shows no current, then why we do not consider internal resistance of EMF2, right? There's internal resistance, and why we don't do that? Now there's a answer to this. This question will be of 3 marks. So you guys should be very, very careful with this, and this comes very often as well. So you're gonna say that this method helps us find the exact EMF of a cell. Why? Since voltage loss is equal to I times current into internal resistance. If current is 0, then V equals to IR will be 0 as well. If there is no current passing, obviously, then from this formula, you put 0 in the current, then the whole V becomes 0. So that's the thing. So hence, we can find the actual EMF. Now, what I mean by this is, as you guys can see, voltage lost is equal to I times R. If I equals to 0, I put it in, then voltage lost will be 0 times R. And 0 times R means that then the voltage lost will be 0. Hence, you will only get the true EMF of the cell. Understood?
Yes.
So that's why it is a good method to find the EMF of the cell without losing any potential. Okay, understood?
Yes.
So this basically marks the end of this whole unit. I'm gonna give you a worksheet now. We can do this right now, and then we'll move forward, okay? So let me see, this worksheet is not enough. Actually, this has a lot of these. Let me check. Kinematics, electric, DC circuits. Okay, we want to do this. This is the most important one. It includes actually everything. Let me put it in. Where you kids at? So DC circuits. All right. Now let's open it up here as well. You guys should open it. Okay, that's bad. Okay, easy. Okay, so this is the one. Now I'm gonna basically do some of these questions, one or two, and then you can carry on. And I'm just here. Ask me anything you want to. I'll help you with that. This sort of question, as you guys can see, it says there's a current from P to R in the resistor network shown. The potential difference between PQ is 3 volts. Okay, we know that. And PD, they've given this, and then they say what is the potential difference between Q and S and S and R. Now, it's pretty simple. As you guys can, if you know, you might realize that this circuit is sort of a circuit that is parallel in this region, like that, with this region. What do you guys say? Right?
Yes.
Do you guys agree? Now check that the total voltage on this side is 3 plus 6, 9 volts, which means if this was 9 volts, after current going through all this section, this should be 0 volts. Understood? So we're finding potentials actually. Now it means that out of 9 volts, 3 has been used here. So 3 minus 9 is 6. So at Q, it should be 6 volts. Understood?
Yes.
And out of those 9 volts, if this uses 5, so at S, the remaining voltage should be 4 volts. Get it?
Yes.
So it means the potential difference, if I attach a voltmeter across Q and S, it will be 6 minus 4, 2 volts. So it means between Q and S, it is 2 volts, like that. And then obviously, if this is this and 5 is used by this should use 4 because the total must be 9. So it has to be answer A. Get it?
Yes.
Wait a second. Okay. Now, like this, you have another question which is similar to this one. It says PQR and XYZ are wires in a circuit. A galvanometer connects QY as a null indicator. The moment you hear this, it means the current here is 0. And why current here must be 0? Because the potential here and potential here has to be same. If there's no potential difference, then there's no difference in the current as well. Do you understand that? Which
Yes.
means that the answer would be potential difference Q in infinite. That's wrong. The potential difference be Q in is 0. That's why. So current can't move the potential difference 0. Get it? So now you guys please start this and let me know wherever you get stuck. Just do it carefully. It's a kind of tricky one, but then once you go through it, you will find it easy. This is very simple, like the first one I did. So yeah, go on, please. Hurry up. Yes. Salma, current cannot move if the potential, like, let's suppose if this was 5 volts and this was also 5 volts, then there is no difference, right? So potential difference across is 0 volts. So current can't move if the potential at both points is the same. Do you understand that? Okay, now try please.